Hello everybody, welcome. This is paper 1 from May 2022, and this is time zone 1. So I think this is actually quite a challenging paper. Alright, 5-mark question. The height of a baseball after it is hit by a bat is modeled by the function height as a function of time, or h of t, is equal to negative 4.8 t squared plus 21t plus 1.2, where h of t is the height in meters above the ground and t is the time in seconds after the ball was hit. Write down the height of the ball above the ground at the instant it is hit by the bat. So for part A, we have this function which is an input-output kind of function. We input some value of t and it tells us the height of the ball at that given time. So we've got some function that tracks the height of this ball for any given time. And the first question is, write down the height of the ball above the ground the instant that it's hit. The instant that it is hit would correspond to t is equal to 0. So let's just substitute that in, and we can write this out more formally, I guess. Let's input a value of 0, and we have negative 4.8 t squared plus 21, t itself is just equal to 0. 0 squared plus 21 times 0 plus 1.2. For a 1-mark question, we can also just know that if we input 0, all of these t values, anything with a t, since it's multiplied by 0, would go away, and we'd be left with 1.2. So that would be fine for a simple 1-mark question. All right, part B, find the value of t when the ball hits the ground. Find the value of t when the ball hits the ground. So the time which the ball hits the ground. There are two ways to solve this. So if we think of just a conceptual idea of what is going on here, we have height as a function of time. The ball at t is 0 is 1.2 meters above the air, and it's a baseball, so it's going to fly through the air, and then it's going to hit the ground somewhere. And where is it going to hit the ground? It's going to hit the ground when h itself is equal to 0. So for our function, if we know here that h is equal to 0, that's our output, we could put an output of 0 and then ask the question, what are the t values that are going to make that true? 1.2. Now, you could potentially n-solve this. That is a possibility, but n-solve, remember, will find the value that is closest to 0. So if we were to stretch this back, for example, that would correspond to, and I'd imagine n-solve would do this. In this case, it would give you a value of like negative, 0.6 t or something like that, which wouldn't make sense. In this case, we're looking for the point after the ball is hit. What is this point? T equals what? And for this question, I think it's probably going to be the easiest to graph it, so let's go ahead and do that. So here we go in the calculator screen. Let's go into the graph. Let's graph this function, negative 4.8 x squared, 4.8x squared plus 21x plus 1.2. All right, it's 21x plus 1.2. Okay. Graph is a little funny. We could probably change our x-axis, and we might want to. So for the next question, I'm just going to change the y value and maybe put the max to something like 50 should probably be okay. Oops, no. Okay. So let's find out where we reach 0 here. Analyze graph, and let's find the 0. Here we go. So after 4.43 seconds, the ball is at a height of 0. So let's go ahead and work that out. Or go back to the document then. Okay, so we know at this point right here, we have 4.43 and 0, and so t itself, t is equal to 0. For a 2-mark question, either of these methods would work. You could set the height equal to 0, and then, whoops, sorry, I don't know where that came from. And the value of t is equal to 4.43. Or you could draw a sketch and then label the coordinate point where the ball has a height of 0 and label the time for that. So 2 marks, 2 method marks, substitute 0, find the value of t, or sketch and then show the coordinate point. Part C, state an appropriate domain for t in this model. Okay, so an appropriate domain. What are they talking about for an appropriate domain? So remember, domain are the set of inputs and the range are the set of outputs. In this case, our inputs are t. In this case, an appropriate set of values for t that we could feed into this model and expect a reasonable result. So given that we have a real-world context, we want to find a range of values of time that will produce a corresponding height of this ball within a certain domain. So what we want is we want t to be greater than or equal to something, or less than or equal to something. So for what values of t can we input to get a reasonable output? We know negative values of t wouldn't make sense. This is before the ball is hit. We know the ball is hit exactly when t is equal to 0, and t is equal to 0 would be acceptable. So we don't need to just have it greater than 0, but t is greater than or equal to 0 would also be okay. And then we know the ball hits the ground at 4.43 seconds, and so anything beyond that wouldn't produce a meaningful result. If we were to substitute into our function, the ball would be, somewhere negative in the ground. So the last meaningful value for our domain, our set of inputs of t, that's going to produce a reasonable result would be 4.43. And remember, a domain for t, they're expecting this kind of inequality. So t is greater than 0, greater than or equal to 0, less than or equal to 4.43. Alright, so just be mindful about the inequalities. They're expecting a range, a set of values, essentially. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.